So let us now make an attempt to answer the big question that we have been asking from quite some time. How does power law come by? What results in this power law? Right? So the intriguing question, just for the sake of revision, let me repose it. So when you try to draw the degree, let's say on the x-axis, so how many vertices are there of degree 1, of degree 2, of degree 3? If you plot that, basically it's the distribution on the y-axis. You will observe a drop like this. The big question is, how does this drop come by? Why does it come? In place of something like this, we observe something like this. Why is this even happening? Right? So many scientists have tried to understand this, and they have come with their own set of hypotheses, and one of the most convincing hypothesis is what is called the preferential attachment. It is called the preferential attachment hypothesis. It's a hypothesis. People have said that there is something called preferential attachment that's happening, because of which one observes power law. And now let's see what exactly is this preferential attachment. Okay. So assume there is a classroom, alright? So this is my classroom, and there is a person who is sitting here, another person, another person. So these three people are mutually friends with each other. Okay, this is a classroom. Let me write that down. This is a classroom, and there are only three people, with only three people to begin with. Let's say 1, 2, and 3. So a fourth person comes. And he tries making friends with two of the existing people. So which means he makes friends with, let's say, 1 and 3. Now wait a minute. Observe the degree of different vertices here. His degree is 2, right? And the degree of this is 3. This degree is 2. And the degree of the node 1 is 3. Correct? So let me put this in a vowel so that you know that I'm talking about degree here. Right? Fine. Now, when a new person comes, look at the story that I'm telling you. You might question, why is this story true? For the time being, you please assume that the story happens to be true. Alright, so there is this person who comes and he observes that there are 1, 2, 3, 4. There are 4 people here of different degrees. Correct? And he prefers to make friends with. So let me do one thing. I think I will remove 1, 2, 3, 4 here for clarity's sake. Let me instead call it A, B, C, D. Okay, let me call this A, and let me remove 2 here and 3 here and 4 here, because it's confusing when I name the nodes as numbers and then also talk about their degree. Okay, let me call it A, B, C, D, and now there is a new fellow, E. He looks at these people A, B, C, D and E and looks at their degrees. A has degree 3, B has degree 2, C has degree 3, D has degree 2. And E must make friends with, let's say, 2 people. Every person who comes inside makes friends with 2 people. Just the way D made friends, E also makes friends with 2 people. And whom will he choose? The story goes like this. He will be attracted to people. So let me write that down. This is sort of important. He will be attracted, a new person is attracted to someone, is attracted to someone who has many friends. Who has many friends. So what do I mean by this? It doesn't mean that he is not attracted to people who have less friends. The point I'm trying to make is he will be attracted to, you know what? It is self-explanatory as I do this small exercise. 3 plus 2 is 5 plus 3 is 8 plus 2 is 10. So now what I'll do is I will write 3 by 10 probability, 2 by 10 probability, 3 by 10 probability, 2 by 10 probability. You will see that the sum of all these is actually 1, and this will be the probability with which E will be attracted to B, C, D, or let's say A. Okay, this is the probability with which E will be attracted. So E will be attracted to A with probability 3 by 10, B with probability 2 by 10, C with probability 3 by 10, D with probability 2 by 10. So what does it even mean? It means that when I enter a classroom, I'll be attracted to people proportionately to respecting their degree. I will be attracted to C with probability 3 by 10 because the degree is 3 and then the total number of degree is 10. So I'll be attracted with degree 3 by 10. So you probably are confused. You're not understanding what has this to do with degree. What has friendships to do with degree? So the point is simple. When you talk to people, a person who has a lot of friends will quickly come to the limelight. He is visible to you. He or she is visible to you. And you would want to be friends with her more than anyone else, a person who's very visible. So the probability of making a new person having a friend is directly proportional to the number of friends that they already have. Alright, so let me assume that E actually makes friends, ends up making friends with C and in fact A, which means what does it mean? I should now update the degree of C. It is no more 3. It will be 1, 2, 3, 4. Right? The degree of C is 4. And the degree of A also happens to be 4. Degree of A is also 4. Okay? So this requires me to erase the degree of A here, and the degree of C also is to be removed, right? And then the degree of A happens to be 4 and the degree of C happens to be 4. And as you would have guessed, I may want to remove all the denominators here. So it is no more 10, you see. What else is it then? It's going to be sum of the degrees, which is 12, correct? It's going to be 12 here. So I'm going to write 12, 12, 12 and 12. E also has 2 degree. So E contributes again 2 divided by 12. Okay. So let me count the total degree right now. E is 2. 2 plus 2 plus 4 plus 2 plus 2, which is, oh no, it's not 12, it's 14, you see. It's 14. So let me remove 12 and make it 14. It's not 12, it's 14. Okay, good. So 14. So now we are getting what I'm doing, right? So 14 for C, denominator, and D will be again 14. The entire process is actually quite self-explanatory. E is also 14. So the entire thing is very self-explanatory. Why? That's because you are just following a simple rule that whenever a new person comes, he becomes attracted to someone who has many friends. It will become very clear once I try writing a new node, let's say F. Now the story becomes slightly complex, but it is easy for you to understand. So what happens? Think about it. Let me just remove these okay, whatever, the degrees here. Anyway, we have the degrees here, so that should be enough. I'm just removing them. So now tell me, where exactly will F become friends with? F has now several options, A, B, C, D, E. But let's assume F becomes friends with only 2 people. Now you might ask me, why is this restriction 2? See, this doesn't look like a real life scenario. What do you mean? Every person has only 2 friends? This is not how it happens in real life. But all I'm trying to say is, let us for a moment consider an ideal model, right? Not all of us will make only 2 friends, but we all know that our friendship budget is sort of the same. We cannot make a lot of friends, we cannot make no friends also. There is some average number. And let's have an ideal world here. Let's say each person makes friends with only 2 people. Okay, F comes here and he needs to make friends with 2 people. So he makes friends with A with probability 4 by 14, B with probability 2 by 14, C with probability 4 by 14, D with 2 by 14 and E with 2 by 14. Okay, anything can happen, and when so this is sort of tossing a coin and then deciding, but you see there is higher probability for F to become friends with A and C, right? So he probably becomes friends with A and with, let's say, D. See, I just said these two are of high probability. Probability doesn't mean that you always will hit on nodes with the same with high probability. You might become friends with anyone here, right? You might become friends with anybody here. Okay, good. So now let us recompute these probabilities and see what happens. Okay, so here goes my next question. Why should I recompute it? Because there will be a new node that's coming in, namely G. Okay, for G to become friends with 2 people, G needs to know the revised probability. So let me remove it and let me again see what is the total degree here. 2 plus 3, 2 plus 3 plus 1, 2, 3, 4, 4 plus 2 plus 1, 2, 3, 4, 5 for A. Okay, so let me write that down. 5 for A, 2 for B, and 4 for C, and 3 for D, and 2 for E, and 2 for my F. So what's the sum? The sum is 5, 6, 7, 10, 14, 15, 16, 17, 18 is the sum. So the denominator will become 18 right now. Okay, I hope you're getting a hang of it right now. As I'm doing this repeatedly, I'm spending some time doing this manually so that you all understand what's happening, and later on we are going to write a piece of code and show you what exactly is happening here. So now G has come, G must become friends with a couple of people, and he will respect these probabilities and become friends with 2 people. And as you can see, there is roughly 1/3 probability that he'll be friends with A, right? And good probability that he'll be friends with C as well, correct? And also, yeah, 3 on 18 is 1 on 6, right? With D as well. So G ends up becoming friends with, let's say, A and let's say C, okay? And so on, and so on, dot, 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 okay? As I keep doing this, the question that I would like to ask you all is the following. Let me write that down so that it sinks into your mind. If I continue doing this process, this for 1000 nodes, let's say, starting from the first 3 nodes, as you know, let me go to the previous slide. We started with this first 3 nodes and we went on adding more and more and more nodes, correct? Right? As I keep doing this, if I continue doing this for 1000 nodes, how does the graph look like? How does the resultant network look like? So, what is happening? Let me go back and see what's happening. A new node always makes 2 friends, right? A new node makes friends with 2 people, always. And the next node that comes makes friends with the existing people, respecting the degree, right? Any node that's coming becomes friends with the existing node by respecting the existing degree, correct? Okay, so look like, how does it look like? It looks like, you will be startled to observe that it looks like a network where the degree distribution indeed follows Power law. Now that's the climax of our discussion. It indeed follows Power law. Such a network which grows by respecting the degrees of the existing people and then grows slowly node by node, it follows Power law. Okay, then let's go back and then see what happened here. You see, nodes who already had higher probability had the propensity to attract new nodes, right? If this continues for 1000 nodes, you will observe that higher degree nodes will become more and more, the degree will become higher and higher for nodes whose degree is already higher. Okay, I repeat that so that it's clear to you. Okay, so let me just write that here. A node with higher degree will attract more edges to it. Why is that? Isn't that obvious? That's what we have been discussing. Because a new node that comes will become friends with the existing node that already has high degree, because that's the protocol, that's the algorithm, right? So he will have many other options, but he will choose that node with a higher degree already. Correct? That is what we discussed here. Right. Correct. So a node with higher degree will attract more nodes to it. Now, this process is called rich get richer process. I'm sure it makes sense. The very terminology makes sense to you. What do you mean by rich get richer? People who already have high degree are getting more and more degree, because that's what the algorithm does. You see? And surprisingly, such an algorithm, such a protocol, such a mechanism of developing networks results in the emergence of Power law. It also, a node with higher degree will attract more edges to it. This phenomena is called the rich get richer phenomena, and we observe Power law in such networks.